We are solving rational equations, and we want to solve the equation by using the LCD and then check for extraneous solutions. So in order to get the LCD, we have to see what factors make up the denominators. Here we have a factor of x. Here we have an understood 1, and here we have x plus 3. So basically our two factors are x and x plus 3, and we have to make sure that we have all those in each one of our terms. So what's missing here? We're missing an x, so we're going to multiply by x over x. Over here, we're missing the x plus 3, so we're going to multiply by x plus 3 over x plus 3. And this middle, we're missing both, so we're going to multiply by x times x plus 3, and in the denominator as well, x times x plus 3. And what we're going to end up with in the numerator here, we're going to get 5x plus 15 over, in the denominator, I'm just going to leave it as the 2x plus 3 times x, and then minus, we're going to have to do this multiplication, so we get x squared times 2 is going to be 2x squared, and 3x times 2 is going to be 6x, and then that is going to have the same denominator, which is going to be x plus 3 times x, and over here we're going to get 2x, and the denominator is going to be the same, which is going to be x plus 3 times x. Now, in order to simplify our life a little bit, we're going to multiply. The next step is multiply by all the fractions by the LCD, and that's going to get that out of those factors out of the denominator. So we're going to multiply by x plus 3 times x, and that's going to be in the numerator. So when we distribute to all the terms, they cancel, and then we're just left with what's in the numerator. So we get 5x plus 15 minus 2x squared. We have to distribute this to both parts. So not only does that negative go to the 2x squared, but it also goes to the 6x. So that's going to be minus 6x, and that's going to be equal to 2x. Now, we see that we have a quadratic because we have the negative 2x squared there. And anytime we have the quadratic, we need to have one side equal to 0, and something else that will really help us is if we have the positive lead coefficient. So rather than bring the 2x over here, I'm going to take all of what's over here and move it to the other side to make sure that I have a lead coefficient that's positive. So we're going to subtract 5x. We're going to subtract 15. We're going to add 2x squared, and we are going to add 6x. And the negative 5x plus the 6x is just plus 1x. Then we're going to say plus 2x squared plus 15. And what we're going to be left with, I'm going to take this side and I'm going to write it over here. So we're going to largest degree first. So we're going to get 2x squared plus 3x plus 15, and that's equal to 0. This is not factorable. And so when we go ahead and do this, the next thing that we can do is we can do the quadratic formula. So we're going to have, let's identify A is equal to 2, B is equal to 3, and C is equal to 15. So we can use those values there, and we're going to say x is equal to negative b plus or minus the square root of b squared minus 4 times a, which is 2, times c, which is 15. And, oh, this is supposed to be a minus 15 here. Subtract 15, this should be a minus 15. And this should be minus 15. So this 15 right here, the c should be minus 15 and a minus 15. And we still have the square root. And all that is divided by 2 times a, which in this case is 2. And so then we get x equals negative 3 plus or minus the square root of, so let's see here, this is going to be 60, 120 positive because negative times a negative, plus 9 is the square root of 129 divided by 4. So this is the solution that we should check right there, but I'm not going to substitute this back in to check the solution, so we'll leave it as x equals negative 3 plus or minus the square root of 29 over 4.